One of the colligative properties is vapor pressure lowering. So when you create a solution, you add a little bit of solute to a solvent and make a solution. The new vapor pressure of that solution will be much lower than the vapor pressure of the pure solvent alone that had nothing added to it. So to figure out how much your vapor pressure has lowered, we'll solve these two example problems. So solution is prepared, solute plus solvent, by dissolving 396 grams of our solute sucrose into our solvent of water. What is the vapor pressure of the solution at 30 degrees C? And they also give us the vapor pressure of water standalone. Remember, vapor pressure is quoted at a specific temperature, so 31.8 millimeters of mercury at 30 degrees C. So here's the important equation that we need to know. So we have the new vapor pressure of the solution. Okay, it's going to equal to the vapor pressure standalone of the solvent. Okay, this is the solvent completely and totally by itself. Here you're going to look it up at the specific temperature. Here they give that to us. It's actually at 30 degrees, 31.8 millimeters of mercury pressure exerted. Okay, times, this is called the mole fraction of the solvent. Okay, the moles of the solvent divided by the total moles of the solution. Okay, so that little x there, cursive x stands for mole fraction. We really don't need the not symbol actually. So mole fraction of the solvent. All right, so we already got P naught of solvent. What we need is the mole fraction. So we have 552 grams of water. We're going to call that our solvent. So let's go ahead and convert that to moles. So our solvent is water. We got to discriminate what's our solute and solvent, right? So water will always be the solvent. 552 grams of water. And we know that for every 1 mole of water, there's about 18.03 grams of water. Okay, getting our numbers from the periodic table. So doing that on my calculator. And now, so that's our moles of water. And also now we want to calculate our moles of our solute. In this problem, they tell us the moles of our solute, I guess it's going to be sucrose, is 396 grams. So we got to convert this C12H22 and O11 to moles. So 396 grams of sucrose. Sucrose is our solute. So C12H12O11, C12H22O11 times, for 1 mole of sucrose has how many grams? So carbon is about 12.01, hydrogen is about 1.01, and oxygen is about 16.01. So I'm getting about 342.45 grams of C12H2211. So let's go ahead and figure out how many moles are there. So remember the grams cancel. So I'm getting about 1.1564 moles of our sucrose. So I'm adding a little extra digits here because I'm in the middle of the calculation. So what is our mole fraction calculation? Our mole fraction calculation, it's a fraction. It's a fraction. Our mole fraction is a fraction, so it's going to be moles of our solvent, 30.616 moles of water. Okay, part over a whole. The whole is going to be the addition of these two numbers of moles. So 30.616 divided by, put our parentheses in here properly, and I'm getting about 0.9636. So there's about 96% water in this solution. So 0.9636 will be our mole fraction. 9636. Okay, so that's our fraction here. And P naught of the solvent alone, that's given to us as 31.8 millimeters of mercury. And now we should be able to solve for the vapor pressure of the new solution at this temperature. Remember, vapor pressure is quoted at a specific temperature. So at a different temperature, we would get a different constant. All right, so let me solve this problem up here. So the new vapor pressure of the solution is going to be 31.8 millimeters of mercury times 0.9636. And on our calculator when I'm doing that, getting an answer 30.64 millimeters of mercury. So 31.8, let's just do it to 3 sig figs, 30.6 millimeters of mercury. And so the idea here is that you added this many moles of sucrose to this many moles of water, and as a result of which our new vapor pressure has dropped from 31.8 millimeters of mercury to 30.6 millimeters of mercury. That in essence is the definition of vapor pressure lowering.